So, good afternoon, everyone. Welcome you all to the next chapter, that lecture number 14, and next chapter, which is strain energy. So, let us, without wasting time, quickly go to the content what we need to study. So, the very first thing, what is strain energy? As we have been doing this earlier, so what is strain energy we already know, but how to calculate the strain energy of a actual bar, that we are going to study in this particular chapter. Okay. So, before that, let us understand the terms which are used in this particular syllabus. Okay. Now, what is strain energy? Can anybody tell me what is strain energy? What is strain? We already know. But what is strain energy? Yes, anyone among you can tell me?
The potential energy that is getting stored by the strain that is exerted in the material.
Okay. Basically, we know that whenever we when we apply the stress to the material, it elongates, and when we remove that stress or force, it regains. So this regaining property is because the material can store that energy which you are using for deformation, right? And with that stored energy, again, when the external forces are removed, the material regains its shape and size if it is deformed in within elastic limits. Okay, so what is resilience? This is another term which we use for resilience. It is basically the strain energy stored but within elastic limit. Okay, so it is the strain energy stored in the material within elastic limits. Okay. Okay. Next is proof resilience. Okay. Just a minute. Okay. Now let us go for proof resilience. So proof resilience and resilience, they are both are the same thing. Here the strain energy is stored in the material within elastic limit, when below elastic limit. But if you calculate the strain energy at elastic limit, which is, we can assume it is to be maximum. Okay, before at that elastic limit, we know that the material is elastic. Beyond that limit, it is not elastic. मतलब जो भी deformation होगा, it is permanent. Right? But at that elastic limit, if I calculate the strain energy, so we can call it as proof resilience. So at elastic limit of the material, the strain energy is known as proof resilience. Proof resilience. Okay. Now, what is modulus of resilience? If I calculate this resilience per unit volume, or if I calculate the strain energy per unit volume, then we call it as modulus. So it is the strain energy per unit volume. Per unit volume. So it is U by strain energy. It is denoted by U also. So U by U, the unit is joule per meter cube. Okay. Now let us understand for basic example, which is strain energy for the bar under gradually applied load. So we know that there is a normal elastic bar which have applied a load P. हमने load P apply किया. Let us assume that A is the area of cross section. Area of cross section. Okay. So we know that the stress developed will be equal to load by area, and the elongation delta L is given by PL by AE. All these formulas we have studied already in chapter number 1. So now what is the strain energy stored? Let us take कि ये जो load apply किया उसके वजह से elongation कितना आया है, तो delta L is the elongation and L was the original length. So if I know the delta L is elongation, then what is strain energy? The strain energy is nothing but the work done by this gradually applied load. जो भी load मैंने apply किया gradually, so वो load ने जितना भी work done किया, that is stored in the form of energy, and that is what we call it as strain energy. So therefore it is work done applied by the load. by the applied load. Now work done क्या होता है? So work done is the average load upon the distance mode. Basic formula for work done is force into distance. That is average load into distance mode. Now what is the average load? What do you mean by gradually applied load? So if I say the force versus time graph, the load versus time graph, if I draw, that is load time relation. So initially at time 0, when we are starting this load, so at that time the load is 0, and then the load is maximum, which is P. Okay, so the load variation is like this. So it is uniform, increasing, gradually increasing at the constant rate. This is the rate. If I calculate the slope of this, it will be the rate at which the load is applied. So that means average if I take, then it will be this section. This will be the average load. So average load मतलब क्या? ये maximum load, minimum load divided by 2. So maximum is P, minimum is 0 divided by 2. So this we get average load. And what is the distance travel? Distance travel is nothing but delta L. But delta L का formula क्या है? It is PL by E. So that is why I have written this PL by E. Now 0 plus P by 2 becomes P by 2 and PL by E. So becomes P square L by 2A. Now here what I am doing is A से multiply divide किया. See here I have written A square and I have multiplied also by A. So now what is this P square by A square? Because we know that sigma is P by A, so P square by A square is sigma square. So which I have written this bracket as sigma square and this AL as it is, P as it is. Now what is area of cross section is A and L is the length. So this is nothing but the volume. So AL represents volume of this specimen, right, or the bar. So therefore if I replace that by volume V, so I get energy is sigma square V by 2E. Okay, and if I take that in the denominator, so U by V, that is energy per unit volume, strain energy per unit volume, or the modulus of resonance is sigma square by 2. Now this is the formula for gradually applied loads. Okay, there can be three types of load which you can apply. We can apply the load gradually, we can apply the load suddenly, and we can also apply the load by an impact. Okay, so the loads can be, as I told you, can be of three types. One is gradually applied, the other one is suddenly applied, and the third one is impact load. Now all of you know this gradually applied means load increases from 0 to maximum. Here impact means direct maximum load is applied, and here impact means the maximum load is applied with initial velocity. With initial velocity. Okay. Okay. So now we have done this gradually applied load, how to get this strain energy. And now let us understand what is the effect of sudden application of load by sudden and impact. So let us go to the next part. So the next part here is the strain energy stored in the bar under suddenly applied load. So if I apply the load suddenly, that means initial and the maximum value, initial value and the final value will be constant, right? Directly if I take 10 kg of load and if I apply directly put in the pan, so initial load is 0, initially and finally there is no time gap, directly हम लोग पूरा का पूरा load apply कर रहे हैं. So that is we call the suddenly applied load. So here because of the suddenly applied load, let us assume that the sigma s is the stress due to suddenly applied load. Suddenly applied load, and this sigma g is due to stress due to gradually applied load. Gradually applied load. So as you can see here, the same formula from here I have taken. The strain energy is nothing but what? ये formula है हमारा sigma square by 2e या फिर p square l by 2a. This is the formula, right? P square L by 2A. So if I substitute that, या फिर sigma S square by L by 2E, whatever you can take. Now what is here, we have put 0 initially, इसको 0 लिखा था, but now here it is, instead of 0 it will be P, that is the maximum load. as we are applying it is suddenly. So therefore यहाँ पे 0 के बदले p आया, p plus p by 2 and dl is the elongation. So now we know that p plus p by 2 is nothing but p to p by 2, that is p. Sigma s, instead of sigma I am writing sigma s because we have applied this load suddenly. Okay, sigma square 2s by al, and here delta l. Now what is delta l? If you remember, so delta l क्या होता है, pl by l या फिर sigma l by e, right? So that is the same thing we have used here. We have written as it is suddenly applied load, sigma s L into E upon E. Now here we can cancel out one sigma, one L and E. So what I left out with sigma s is equal to sigma s upon 2 into A is equal to P. And therefore sigma s is 2 times P by A. But what was P is the load and A is the area. So load upon area is the sigma gradually, which we have calculated. So here we understand that when you apply the same load suddenly to the member, the stress developed will be twice the earlier one. So it is very, very important for us to know whether the load applied, the maximum load which is applied, whether it is applied gradually or whether it is applied suddenly. If you applied it suddenly, the stress factor will be 2. That means the stress will increase directly twice. So this is very important to remember. You may be asked in MCQs or short answers. Okay. Now let us go for impact load. Now what do you mean by impact load? So as you know, so how the impact load can be given? So let us assume that this is the P load P. Okay. So this load P is the maximum load, which is impact load means certain with certain velocity, right? But अब ये impact load कैसे देंगे हम लोग? For example, we will release this load from certain height h. So when this load comes down, what will happen? It will gain some kinetic energy, and when it impacts on this particular collar, it will have some kinetic energy. With that velocity, it will impact and it will give some elongation. Surely this elongation won't be similar to gradually applied load, won't be similar to suddenly also, because here the load is same, but it is coming with some initial velocity. So here, whatever now, how we can calculate that energy? So basically, this when this impact loads comes here and comes in contact, after that ये यहाँ पे नीचे तक displace होगा, right? So initially जब ये load है, उसके पास energy था, kinetic energy, so it was having some kinetic energy. Sorry, at particular height it was having some potential energy, which is then converted into kinetic, and with that kinetic energy it is impacted on the collar, and the collar get displaced. So when the collar get displaced and it reaches to the maximum value instantaneously, after that it will come back again. Okay, so for this instantaneous stage, whatever is the elongation which is produced due to that impact, whatever the strain energy stored is nothing but the potential energy earlier this collar was having when it was at certain height. So that means the earlier potential energy that weight was having is converted into the strain energy instantaneously at the maximum elongation point. Okay. So this is how we can equate. So what is potential energy? So potential energy is P is H plus delta L. This was initial height H, and यहाँ पे नीचे तक जाएगा तो total height is H plus delta L. And what is the strain energy? We know the formula, sigma square AL by 2E. So here I have written sigma I. Sigma I stands for stress due to impact load. H is the height of impact. From which height the impact load is falling. Okay. P is the maximum load. A is your area of cross section, that is already there. Delta L is the instantaneous elongation. Instantaneous elongation. Are you understanding why I am calling it as instantaneous elongation? Because this won't be forever. Okay, this won't be forever. For example, if you are in a lift and you jump it, what will happen? The elongation comes instantaneous. You will go down and the floor will again come back. So the maximum your weight, जितना तुम्हारा maximum mass होगा, उतना ज़्यादा वो नीचे जाएगा, but वापस से ऊपर भी आएगा. तो जो maximum displacement होता है, that is instantaneous. It's for a fraction of a second, and again it will regain the shape. Okay. So therefore, the delta L is the elongation which is called as instantaneous elongation. Now let us understand how to calculate the sigma I. So we have equated potential energy and the strain energy. The potential energy is mgh होता है, but g अगर मैं m का mass into gravity into height. But here we are having this load in Newton, so no need to take g. So your load into height. Okay, Newton into meter, that is Joule. So therefore, P into height h plus delta L, and this is sigma square I to E by AL as it is. Now sigma square I as it is. What we can do here is, instead of delta L, I can write down sigma I L by E. That is stress into original length upon modulus. Okay, so now we can multiply this P inside. So it will become PH. Here it will be P into sigma L E by A. So that we have written on this side in a negative, so with a negative sign. So here we have this sigma I square by 2E into AL into P sigma I L by E and into PH. So here sigma I is the variable. This is the variable which I want to find out. P is the constant. This is constant, na? Because we know the initial maximum load and we know the initial height at which it's kept. So pH is a constant. So what we can do here is, if I want to find out sigma I will convert it to quadratic equation. You can see here the degree is 2, here is the degree is 1. So we can convert it to quadratic equation. So for that, what I'll do is AL by 2E से मैं सब जगह पे divide कर दूँगा. So if I divide AL by 2E on to all three terms, here AL by 2E will be vanishing. यहाँ पे cancel होके बचेगा 2P sigma I by A, and here it will be 2PH by A. Now here in this particular step, I have added P square by A square on both sides. See here, I have added on both hand sides. So why? Because by adding this, I can convert it to the complete square formula. You can see here how to determine what to add, because if you have solved quadratic equations, you must be knowing it. So whenever we need to solve a quadratic equation, before that we need to form a quadratic equation. For that, we can add a complete square term. What is that complete square term? It is half into the middle term into the first term. So here half into middle term. Okay, so we have added this, and P square by A square I have added to both sides. So if I see it is sigma I को अगर मैं A पकड़ूं, P by A को B पकड़ो, तो it is A minus B the whole square. So therefore it is sigma I into minus P by A the whole square, and here it is as it is we have kept. Okay, so if I want have this square and if I want to take the root of it, so here there will be a root. So sigma into P by A is equal to root of this, and if this P by A goes on this other side, it will be P by A plus P square by A square 2PH by AL. So instead of P, you can write down W also. That is, W is the weight of this particular impacting load, or H is the height. Whatever the notation you want, you can write. So once you know sigma I, you can easily calculate delta L, which is that was given by sigma L I into L by E. That is the instantaneous elongation. Okay. So here, this part we need to study, and we need to solve some questions based on this. Okay, are you understanding this?
Yes, sir.
Okay, so once you know this, now we can go ahead to discuss the next part. I will solve some few questions, because the questions are very simple, formula based will be there. So we will solve some questions just to have enough practice. I can see here question number 1, a 200 kg weight is dropped on a collar at the lower end. So there is a 200 kg weight. Here load P is given as 200 kg. So we need to convert it. So it is 200 into 9.81. How much it will be?
1962.
1962 Newton, right? On a collar
Yes.
to a lower end vertical bar of 3 meter long. So original length of the bar is 3 meter. So that we can convert it to 3000 millimeter. Okay, long, and 28 mm diameter. So the diameter is 28 mm. So once I know the diameter, I can simply calculate the area of cross section. Pi by 4 d square. How much it will be? Can you tell me? Yes.
615.4.
Okay, 615.4.
75. 4 नहीं 75.
0.75.
Okay, so 0.75. Okay. If the maximum instantaneous stress is not to exceed 120, so they are asking you to find out the height if sigma instantaneous stress, which is due to the impact load, is given by the maximum value is given as 120 MPa. Okay, what is the corresponding elongation? So they are also asking you to find out this delta L, and the value of E is given to you, that is 2 into 10 raised to 5. Now this is simple 3 or 4 mark question because it is very simple based on the simple formula which we have just derived, that is sigma instantaneous is P by A plus square root of P square by A square plus what is that formula, 2PHE by AL, 2PHE by AL. Now out of this the only H is the unknown, other things are known to us. So sigma I is 120, this load is 1962 divided by 615.75 plus square root of 1962 by 615.75 the whole square plus 2 into 1962 into H into E, which is 2 into 10 raised to 5 divided by, this is MPa, divided by area, that is 615.75 into the length, which is 3000. So you have to simplify this and get the value of H for me. You will get in mm, that you can convert or no need to convert also. Yes, once you know this, you can find out delta L, which is sigma I into original length by E, that is 120 into 3000 divided by 2 into 10 raised to 5. So 3 zeros, 1 0, 8, 10 bachega. Okay, 2 sigma, so that is 1.8. Yes, how much is H? Yes. Anyone?
So 32.09.
32.09. Is it correct, everyone? Okay. So assuming that that seems to be correct, so you can go ahead. So if it is for 4 marks, of course the 3 marks will be here and 1 mark will be here. Okay. So now next. So these are the simple kind of problems which you can get on strain energy. So the next question is, a bar of steel 3 meter long is 20 diameter for 1.5 meter length and then 15 for remaining length. Okay, so that means let me draw the diagram. There is a bar which is having different cross section, right? How much is this length? Is 1.5 meter and this length is also 1.5 meter. Here the diameter is 20, here it is 15. Okay, the collar is attached to the bar at the bottom. Here at the bottom we have attached a rigid collar. Okay, a mass of 100 kg falls on the collar to height of 4 centimeter. So from here, let's say the mass of 100 kg means load P is 100 into 9.81, so that is 981 Newton falls from certain height h, which is of 4 centimeter, so that is 40 millimeter. Find the maximum stress produced and what is the instantaneous elongation in the bar. Now we don't have a single bar, we have a composite bar. So how we can calculate? Yes, anyone? First of all, let us call this as first bar, second bar. For first bar, the area A1 can be calculated by pi by 4, diameter D1 square, pi by 4, 20 square. Just give me the values. For A2, it is pi by 4, D2 square, pi by 4, 15 square, whatever. At least you can give these values.
A1
314.15.
4.314.
314.15.
Huh?
A2 176.714.
314.15 millimeter square, and this is
176.71.
71 millimeter square. Okay. Now let us assume that यहाँ पे जो स्ट्रेस आएगा अलग होगा दोनों, बिकॉज एरियाज अलग है. यार यहाँ पे जो स्ट्रेस आएगा वो सिग्मा 2 है, बराबर ना? नाउ कैन यू, अभी ये जो भी स्ट्रेस आएगा इसके ऊपर, ठीक है, तो द टोटल लोड इज नथिंग बट व्हाट, जो भी टोटल लोड है, इफेक्ट है, P विल बी इक्वल टू जो फोर्स आएगा, इम्पैक्ट फोर्स इक्वल. लेट अस अज्यूम दैट कि अभी यहाँ पे तो हमने इम्पैक्ट लोड दिया, बट अज्यूम दैट कि अगर मैंने यहाँ पे कोई इमेजिनरी लोड P लगाया होता, ठीक है, इमेजिनरी लोड है, तो ये लोड ये दोनों बार सीरीज में होने की वजह से लोड तो दोनों पे सेम ही एक्ट करता. तो मतलब यहाँ पे जो स्ट्रेस सिग्मा 1 इंटू A1 है इज ऑल्सो इक्वल टू सिग्मा 2 इंटू A2, राइट? ये तो होना ही चाहिए, बिकॉज अगर लोड सेम है दैट मीन्स स्ट्रेस अलग होगा, बिकॉज एरिया ऑफ क्रॉस सेक्शन अलग है. So I know the area, so can I get the relation between sigma 1 and sigma 2? So can I get sigma 1 is equal to 176.71 divided by 314.15 into sigma 2. How much is this? Yes,
0.56.
0.56
56.
sigma 2. So are you understanding? I have just got the relation between those two. Now whatever यहाँ पे इसके वजह से जो भी इलोंगेशन आएगा टोटल में, वो इलोंगेशन दोनों शेयर करेंगे, मतलब दोनों कुछ ना कुछ एक्सटेंड करेंगे, राइट? So can I write the total elongation delta L is nothing but delta L1 plus delta L2, right? Now what is delta L? What is delta L? It is sigma 1 into length 1 by area 1, sigma 2 length 2 by area 2. Is it not? बराबर है?
Yes, sir.
Yes, sir.
तो कितना आएगा फिर? I can solve this na in terms of sigma 1 or sigma 2. Let us solve it. Let us solve it. Okay, so delta L is sigma 1 into what is the length L1? 1.5 meter, or we need to write down 1500 because we are working in millimeters. So let me write down in 1500 divided by area A1 is 314.15 plus sigma 2. We can sigma 2 also, rather I would have written this way. Sigma 1 को भी substitute कर लेते, so that we will get answer in terms of any one, this one. So sigma 1 I will write down as 0.56 sigma 2 into 1500 divided by 314.15 plus sigma 2 is as it is again 1500 divided by 176.71. Okay, so if you solve this, can you give me the relation in sigma 2?
11.16.
No?
11.16.
11.16. पक्का ना?
Yes, sir.
करो जरा, कुछ गलत
Yes,
तो नहीं
sir.
सबने
सही
किया? Okay, ठीक है. So I will write down once again. Sigma 2. Okay, so let us take this is equation 2. So we have delta L. Now, so here अभी हमने क्या किया था? मैंने कुछ इक्विवेलेंट लोड लिया था, राइट? ये जो लोड लिया था वो इक्विवेलेंट लोड था ना, कि अगर मैं इसको ऐसा खींचता इक्विवेलेंट लोड से, तो जाके ये होता है। बट अभी क्या हो रहा है कि ये जो भी स्ट्रेन एनर्जी डेवलप हो रहा है, जो भी स्ट्रेन एनर्जी, वो किसकी वजह से हो रहा है? तो ये जो लोड मैंने इम्पैक्ट की वजह से फेंका, तो ये जब यहाँ पे था हाइट पे, तो उसके पास था पोटेंशियल एनर्जी. So this potential energy is now converted into strain energy, right? This is converted into strain energy. So can I use that relation? The potential energy of impact load is equal to the strain energy, right? Barabar? Is it not? So what is the potential energy? The potential energy is load, which is 981 into height. Height कितना है वो? 40 mm plus elongation delta L, right ना? Plus elongation delta L, H plus delta L होता है, और ये 981 का impact load है. That is equal to what is strain energy? अभी ये strain energy दोनों इसमें स्टोर होगा. पहले वाला strain energy रहेगा sigma 1 square by 2e into area A1 into L1 plus sigma 2 square by 2e into area A2 into L2. अभी इसमें से देखो क्या क्या नोन है. तो ये 981 एज इट इज लिखता हूँ, 40 एज इट इज. डेल्टा एल को मैं लिखूंगा 11.16 सिग्मा 2, सिग्मा 2 is equal to what is sigma 1? It is 0.56 sigma 2, तो इसका स्क्वायर by 2 into 2 into 10⁵. रादर ये दोनों ये एक ही रहने वाला है सबके लिए, तो मैं ऐसे ही लिखता हूँ. इंटू एरिया इज 314.15 इंटू लेंथ इज 1500 प्लस सिग्मा 2 का स्क्वायर इंटू 176.71 इंटू 1500. सो यहाँ पे देखो सब जगह पे एक ही अननोन है, विच इज सिग्मा 2. सो वंस यू विल गेट सिग्मा 2, you will get sigma 1 and you will also get delta L. Yes, can you give me the answers? Of course, you will get a quadratic equation in sigma 2 that you have to solve and get the values. Yes. अरे एक मिनट, we have done one mistake. You have not noticed, I have written a wrong formula. It is sigma L by E होता है, right? So here also it is wrong. Here it will be 2 into 10⁵. 2 into 10⁵. Now tell me how much will be this?
Zero point zero
0.42
one
plus
0.01
17.
0.0117. Okay. Done? Now tell me sigma 2, sigma 1 and sigma delta L. Complete? Who is calculating? अच्छा difficult है solve करना. So if you are not getting, I will have to solve. Yes. So you should get something like this into sigma 2 square minus 981 into 0.0117. Yes or not? 1.56. अरे बताओ किधर गए? हेलो
Yes, sir. एक second.
सॉल्व कर रहे हो कि नहीं?
कर रहे हैं सर. सही करो वापस बैक स्क्रीन करना.
सर 200.635 आ रहा है.
हाँ ठीक है बराबर है. तो सिग्मा 2 कितना है हमारा?
0.635.
200.635 MPa. And what about sigma 1 then?
One 2.35.
0.35 good. And what about delta L? Instantaneous elongation?
थ्री 3.41.
ये जरा चेक करो वापस.
सर 2.35 है क्या?
117 है ना इधर. हाँ
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 हाँ सर.
2.3.
हाँ सर 2.35.
Okay. So these are our answers. So are you getting this?
Yes, sir.
So
Yes,
this
sir.
is a
Yes, sir.
simple chapter in which this kind of numerical will be there. I haven't taken the numerical on the these questions, like if it is suddenly applied and if it is gradually applied, because very simple formula is there, sigma square by 2e. Even if they ask you the simple problem, in the same problem they will ask you to find out if the load is applied gradually, what is the stress, and if the load is applied suddenly, it will be double of that. So sometimes this is mostly important for MCQs or the direct short answer question where it can be asked even in for vivas. And suddenly and mostly whenever the numerical will come, it will come on the impact load. Okay, so this is what the strain energy is stored when the actual load is applied. Similarly, strain energy in bending, strain energy in this one, because we know strain energy depends on sigma stress. So if you know how to calculate stress in bending case, if you know the stress in torsion case, you can find out the strain energy in those applications also. The formula still remains same, sigma square by 2e into area into length. Okay. So most probably the impact load will be the maximum time they ask questions on impact load. So you have to remember this formula, or else you have to remember the derivation. Anyway, you can solve it. Okay. So with this, we have finished with the 9th chapter also, that is strain energy. Okay. So